Chapter 5.9 deals with complex numbers, and basically a complex number involves us having to take the even root of a negative number. So if we look at stuff that we did before, in Algebra 1, whenever you encountered a problem that looked like this, say the square root of -1, your teacher probably just told you to put undefined. Alright, because it wasn't defined to you at that time. Well, what we're going to learn now is that if we take the square root of a negative number, say just -1 again, what we have is this imaginary unit called I. And basically I was a number that was created that allows us to take the even roots of negative numbers. And even though I is an imaginary number, it is definitely used in the real world. I know electrical engineers use them when they're programming video games at Chuck E. Cheese. Make sure that you guys understand your imaginary numbers if you guys are going to work there. So why don't we just do a couple of examples of what an imaginary unit looks like. If I'm going to take, say, the square root of -4, what that is I can actually separate the square root of -4 into the square root of -1 times the square root of 4. Well, we know that the square root of 4 is 2, and we know that now that the square root of -1 is I. So what I get is I times 2, or 2I. Move that up. Likewise, if I was to say take the square root of -64, what that is that is the square root of -1 times the square root of 64. And what I get is 8, and then I get I, which is 8I. Now, when we're doing the quiz and doing the homework, I don't expect you guys to split this apart. If I say gave you the square root of -81, just jump straight over to 9I. So to make it harder, sometimes they might give you the square root of -12. Well, from here, it's just like simplifying the square root of 12, which is 4 and 3, in which case the 4 breaks out, and it is a 2 rad 3, except it's negative, so we say 2I rad 3. All right, so that's how you simplify radicals when there is a negative number on the inside. Okay, let's get into some operations with I. Okay, so let's take a look. If I'm going to make an example number 1 here, if I say -3I times 8I, the operations are pretty simple. You just multiply the numbers together, you get -24, and then you get I times I. Well, I times I is I squared, and I squared actually has a value. So let's take a look at our definition again. It's the square root of -1 equals I. Therefore, if I say squared both sides, right, what I get is I squared equals -1. All right, so please make sure you guys remember this definition here, is that I squared equals -1. It's going to be key in some of the things we're going to do later on. So getting back to example number 1 here, if it's -24I squared, that's really -24 times -1, which is +24. Let's do another example. If I say have -6 times rad 10, well, I can't simplify any of these right off the bat, but remember I told you guys to think like Tai Chi, just have your brain be able to flow. Sometimes you have to multiply before you simplify, like this time. We've got the square root of -60, and now I can break this apart. Well, this is really rad 4 times rad 15, or more specifically rad -4, so what I get is 2I rad 15 as the answer. Alright, so let's do a couple more difficult ones. If I say the square root of -169, well, that's kind of a perfect square right there. That's 13I. Pretty simple. And the next example, let's do something a little bit more tricky. -36 m to the 4th n to the 6th. Well, the square root of -36 is 6I. The square root of m to the 4th is m squared. And the square root of n to the 6th is n to the 3rd, but remember, because it's jumping out as an odd exponent, you must put the absolute value bars around the n to the 3rd. And the last example in this is, if I say 2I quantity squared, remember the power showers into the monomial, so I end up with 4i squared, which is negative 4, because I squared equals negative 1. All right, let's keep going. Simplifying I to the x power is basically like simplifying I to like some kind of crazy power. But let's take it easy at first. If I say I to the first power, or actually, well, back up. If I say I to the 0 power, well, that's 1. Anything to the 0 power is 1. I to the first power is I. I squared is negative 1, right? We learned that from our definition up here. I to the third is, well, that's I squared times I, which is negative 1 times I, which is negative I. And then I to the fourth is I squared times I squared, which is negative 1 squared, which is 1. So it starts to repeat itself, this cycle here, but the cycle isn't really super important so much as it is the technique that you get from the cycle in order to simplify I to what I consider crazy powers. For example, I to the 13th power. I do not want you going down this list until you get to 13. It's doable, but I don't recommend it. What I recommend you do is whenever you're encountered with an odd power of I, what you do is you pop an I out of there, leaving you with I times I to the 12th. Well, now what you're going to do is you're going to say I times I squared, and then I squared to the 6th power. If you guys see, 2 times 6 equals 12, which is where the 12 went. And I times, well, I squared we know is negative 1 to the 6th power. And we know that negative 1 to an even power is 1, and we have 1 times I, which is I. And sometimes it just takes a few of these to really nail it to the wall. Why don't we do I to the 29th power? This is going to be I times I squared to the 14th power. So I've got I times negative 1 to the 14th. We got the same kind of answer here. Negative 1 to an even power is 1 times I is I. Number 3. Let's do an even power, I to the 12th. Well, I to the 12th, I don't need to pop an I out of there. All I know is that I squared, I can reduce that. I squared times I to the 6th, which is negative 1 to the 6th power, which is 1. Let's do one more. If I say I to the 39th power, that's going to equal I times I to the 2nd power to the 19th power. This is negative 1 to the 19th power is negative 1. Negative 1 times I is negative I. All right, so that's how you do solving, or rather simplifying I when it's being raised to a really crazy kind of power. Solving equations with I. Solving equations with I would look kind of like this. 4x squared plus 36 equals 0. You can solve it one of two ways. You can either try and factor this thing, or you can just go ahead and subtract 36 from both sides. So I got 4x squared equals negative 36. Divide by 4. X squared equals 9. Take the square root, and x equals plus or minus, I'm sorry, this should be negative 9. Plus or minus, remember, taking the square root of a negative number, 3i. Let's try another one. Say x squared plus 81 equals 0. I'm going to subtract 81 from both sides. I got x squared equals negative 81. Take the square root, x equals plus or minus 9i. You might encounter a problem in your homework, in fact you will encounter a problem in your homework that will ask you to find the values of m and n that make each equation true. So if we look at an example here, like say m plus 2n plus 2m minus ni equals 5 plus 5i. Okay, I'm going to give you guys the most basic version of a complex number. A complex number is expressed as a plus bi, where a is the real component and b is the imaginary component. All right, b is the imaginary because it's attached to the I. Well, all you have to do here is identify what's the real and what's the imaginary. Well, the real is m plus 2n. The real on this side is 5. The imaginary portion is 2m minus n, and the the imaginary portion is 5i right here. So why don't we go ahead and associate these? So I get m plus 2n equals 5, and then 2m minus n I equals 5i. On the bottom, I'm going to go ahead and divide out my i's. So what I get is 2m minus n equals 5. On top of that is m plus 2n equals 5. Now I've got a system that I can solve. I'm going to go ahead and multiply the top by 2 to get negative 2. Negative 2m minus 4n equals negative 10. Those are going to cancel. I end up with negative 5n equals negative 5. N equals 1. I'm going to plug that into the original. So m plus 2 times 1 equals 5. M plus 2 equals 5. Therefore, m equals 3. Okay? So the point of this is to be able to match up the real to the real, the imaginary to the imaginary. And then you set it up as a system and you solve it. So there is your introduction to imaginary numbers. Please make sure that you will no longer put undefined when you are taking the square or even roots of negative numbers. Right? They are no longer undefined. They are defined by the imaginary unit. All right, that's all I got for you guys. See ya.